At a very broad level, from an asset management perspective, all of this is not just about a project or a single team or even design and construction, even though is part of this. We're seeing over and over again that owners are really driving a lot of the discussion. The National Institute of Building Sciences, the work that we're doing with NIBS too, has been focusing a lot on how do we help owners ask the right questions, because they have a lot of this knowledge and information just in the wrong format usually.
Owners are missing out on the benefits that the technology are bringing to the architects, the engineers, and the contractors. And it's falling off the face of the earth before it gets to the owners.
The owners drive a lot of the discussion. I think they're obviously the ones that fund a lot of this, and they have a lot of their standards, often with thousands of pages of PDFs or documents or in people's heads, and converting it into a machine readable format has been a pattern that we've seen way before you even start into design, construction, and asset management.
We have worked with a lot of different owners in the past. And one of the things, a recurring theme that we have seen is oftentimes when you are in the day-to-day trenches and the work that you're doing, oftentimes you don't necessarily get the opportunity to step back and look at new opportunities to actually go ahead and not only leverage the information that you're always working on a day-to-day basis, but to be able to say, oh, you know, wow, we've been conducting our businesses in this manner, and this has always taken 8 steps. But then with some of these new tools and technologies and ways that we can collaborate, maybe that could get truncated to like 2 or 3 steps. And then so one of the things that we're always interested in is as we do these BIM storms, we ourselves are actually learning and testing and trying to push the boundaries of how we can go ahead and improve those business processes as we look at all these different kinds of information that the owners are always looking at and working with.
So last time we actually gave some examples of this. So when we started building the healthcare requirement spaces, the reason we were able to use ChatGPT to even ask the database, what do we need for a clinic, is because this particular set of healthcare owner requirements were converted into a format, a machine readable format that's accessible and programmed to BIM. This is just one example, but because it has all this data in there, you could say, give me a clinic, what do I need in it? It goes and grabs the pieces that are needed and starts to assemble, well, here's an early program requirement. That sounds pretty simple when you just kind of mention it like that, but in terms of having a machine do that, it's pretty interesting because it's kind of understanding, okay, if you have 5,000 patients and this is what you need, we still had to review it and correct it. And that's the back and forth with ChatGPT that we showed last time. But this is the healthcare requirements of this owner for spaces and for assets. These are a list of asset types that are important for healthcare planning in this example. And you'll see this data reappear again later on when Cyril comes on to talk about actually making its way into the design and construction and handover into operations. How do these assets get tracked? If an owner has a list of assets with very simple IDs and information related to them, they can describe that in a format that architects and the industry and machines like ChatGPT can understand. Another example of an order in which we had several sessions ago with the California community colleges was at the state level. The entire state of California has a space inventory because they use the space inventory to track needs. So what is the demand for a new community college or a new classroom, or a new laboratory, or a new clinic? Because they have this in a database, and because that database is accessible, then in our case, with our work with them, we're able to link directly to it and pull the space inventory into other applications, including planning, design, and then off into operations. And what we've seen over and over again is that many owners really struggle with just the basics of keeping track of their inventory of spaces, let alone 5,000 buildings and several 100,000 spaces. But once you have it in a database and it's made accessible, then you can start linking it to graphics, whether they're graphics of a floor plan of a building or graphics of a map, and then being able to start running scenarios and plan with that data. So this was the Build LACCD and LA Community College District that presented with us several sessions ago with the Asset Leadership Network, and for their capital planning and also into facility management. So with that, what we did, and I won't go because we presented the details last time about what we did, but I'll just start at the beginning. You can go back into the previous session, but essentially we started in saying, well, what if we used ChatGPT and kind of taught it the owner's requirements to take this data that this owner has in this database and store it in a table in ChatGPT. So that's a question I asked, and you'll see throughout this presentation, there's kind of these pink squares that are humans asking questions, basically, and then we have green squares of the response that says, sure, here's a table. It creates a table. And then we asked it, can you create an architectural program with that? And then it actually said, okay, here's a program. So it's using the rules that we fed it, say, what do we need for a clinic? And it starts generating the beginnings of a clinic. There were several back and forths here, including some errors that we caught. So this is what Jack mentioned earlier. It's not perfect. So you have to kind of watch it. And you also, we found over and over again, it's really kind of, how do you ask the question? It's just like you're having a conversation. If you don't ask the right question, you don't get the right response. That use case there even happens even before you use AI, and that's part of the BIM storm, right? When you start working in a BIM store in a workshop in a charrette like this, you start seeing other people's decisions, then you can react. If you can't see it, you can't react. And that's often the challenge in a lot of these complex workflows, that things happen in the background they don't see and they keep running for a month or so. And then you say, well, that's a mistake. We want to try and catch those early. And that's kind of the agile approach to, okay, let's expose everything and the decisions we're making. So that was the initial, let's create a clinic, the program. So that with this list, we were able to load it into our program now. We create our own applications for many years. We basically loaded that table into our program, and it spits out a result that kind of looked like this. Here are all the spaces that you need for a clinic. And this happened within minutes, basically. We built an app just with that database for this clinic. This was just, it takes a few minutes to build a simple app, but we have our own apps as well too. But the ChatGPT API is interesting because it will start to allow us to connect directly rather than feeding the data manually into the prompt. Once we had this initial program for a clinic, we said, okay, yeah, this is going to take a year to build, but if you have had an earthquake or if you're planning for a disaster and you want to have a field clinic, temporary field clinic quickly, what can we do to build a temporary field clinic? So we asked, we basically created a fork over here where we tried a different thing. We said, okay, since this clinic will take 12 months, give us a subset of spaces that we could build for a temporary field clinic. That was a question we had a couple of weeks ago. So it created the new requirement here. And since then, actually in the last few days, we took this requirement of a subset and we created a field clinic that kind of looks like this. So this is actually in the model as well too. It's a temporary building, a smaller building than the full set. So there's kind of several things happening in parallel here. We sent this to CDV Systems and Collectus and Cyril and said, what can you do with this BIM that we created through ChatGPT and the Onuma system with program to BIM? And can you take it into Revit and take these requirements that came from the owner? Remember the owner requirements I talked early on? The owner says how many air changes they need, all this kind of stuff here. Oh, one interesting side note here. I also fed into ChatGPT. This is what the owner thinks they need for air changes and exhaust and the type of floor finishes. If we're going for LEED Platinum, what adjustments should we make in terms of sustainability and carbon, reducing our carbon footprint? And it actually gave a recommendation, which we fed back into the model as well. So it's been kind of this looping factor where we kind of get some results, we feed it back in, and it gives us some other ideas. So with this model, we handed this to Cyril. We also refined the layout. So this is kind of the rough layout, the first rough layout, human-generated layout. In other words, we dragged the shapes into what we think is kind of a layout that might make sense. Notice there's a lot of blank space in between, so it still needs an architect or an engineer or another machine to actually figure this out. But this is our BIM in the Onuma system now that we then refined the layout, and we went back and forth with Cyril. And then Cyril imported this into Revit. We have a plugin from Onuma system to Revit with a format called BIM XML that lands all the spaces, the components, the objects as families, and then
what we've found is that these owners receive models all the time from the builders, from the architects, from the contractors, engineers, and they don't know how to use them. And from our perspective, the key is the models need a consistent data structure that can be passed across all trades. So we always, I'm going to take a big step back here. Here, we always ask the question to the owner. The first step to managing an asset is to locate it. That's the key. And these models that are being built by the architects, engineers, and contractors are ideal for locating the assets and then ideally attaching all the data you need to it. So from our perspective, we're sort of taking it, from pre-design through final submissions by the AC teams, and then from there it goes to some kind of FM and GIS program. So what we did is we received the model from Kimon, and we started incorporating our data structure in that model. And it includes not only design and documentation data, but it also includes, and this is per asset, and rooms and across all trades, architectural structure and MEP, includes data for design and documentation required by the architects, manufacturing information required by the GC or the subcontractors, and then operations and maintenance data. Because again, if I've got an air handling unit sitting in a model, that's the best place to be able to gather the data, enter the data by the various trades, and then harvest the data. So what we did is we have this program. We have Collectus. It's a library in the cloud, but it includes this entire data structure, so that as these assets are being dropped into the models, whether it's assets coming actually from Kimon's system or assets coming from Collectus, the data structure is available for the teams to fill in. So what we did is we took that data structure, and the key for us was in this particular example, we were loading in a subset of the project. Actually, I'll show you an example here. So we said, well, these assets that Kimon has, here's my live screen. There were key assets regarding purchase order, installation date, warranty date. These were key important values that any owner would want for a particular asset. And again, we chose a room. We have data within that room, and this model becomes priceless in terms of the data structure. Again, from this setup that Kimon has, he can take the models and bring them back out to a data structure that can be usable by the owner for whatever FM or GIS programs that they're using. So from our perspective, these models can become they're data rich. That's the key. Again, with our experience with working for 20 years with architects, engineers, and contractors worldwide, the data structure had to be more consistent. Every architect that does projects, even internally with a firm like NBBJ, as an example, different teams within NBBJ are doing different types of data structures within the models, and the owner has to somehow translate that. And sometimes the data is there, sometimes it's not, and it's just inconsistent. So,
as long as there has been BIM, there has been problems with information getting locked in the model. The models are too big, and
correct.
Frequently owners throw those models out and walk around their buildings and collect serial numbers off of equipment. A total waste of time. So Collectus was created, and much of what you do at CDV Systems is help the owners break through the logjam of the model so that they can extract the disparate information in these different formats and have it be useful. So that's a great solution to that problem. And what you're seeing now in this it's only been a few weeks that you're working with Onuma. If owners require a structured approach to their asset management at the beginning, from the very beginning, then the work that you're doing is even more efficient, and they're able to get that information even easier.
As an example, University of Virginia, they have Collectus. It's a 3-year subscription, and they provide this entire library to all of their team members, architects, engineers, and contractors for any of their projects. There's no charge for them to use this product, but then it allows the UVA to actually view these models and to validate the models to make sure that they're in compliance, because there are tools within Collectus that allows an audit feature to check the model. Because if someone takes a door family from, let's say, a BIM city on the internet and drop it into the model, it's not going to have the same data structure, and thus there's a disconnect there. This audit check checks the model to make sure that everything within the model is compliant, whether it's a component family or a system family or an annotation family. Now I'm digging into the weeds, but it's a tool it's a simple tool that the owner can use to check the models.
Work with a lot of owners struggling with this exact problem, that they have a lot of consultants that are very advanced in BIM, but they have more than one building that they're working, for example, right? The owner has multiple projects, multiple buildings. And even if each AE has a perfect record of using BIM for that delivery, it's not consistent for the owner, because the owner's needs are, we want consistency across our entire portfolio. We don't want 100 great ideas. We want kind of the base level there. If we, and this was a use case here, I think, we said if an owner has a structured set of information, whether it's very basic or whether it's more advanced, like we talked about the database of spaces and equipment, then it helps the owner actually drive the discussion back to the AEs for delivery back. I think that's what we've talked about earlier too, but what you reinforced here, I think that's a very important point that should not get lost, because we know this is a challenge across the industry. So this fits right into the ALN presentations that we've been doing for several years now, that we say that data is an asset. This is truly how you make data an asset, because it's not just a liability that you have to go and collect it twice.
Right.
You collect it once and you use it over and over again, right? And you use it across the portfolio, so not just a single project. Exactly. And the same data, which we'll show later, can make its way back into other systems as well too. So it's not a dead end. That's another important concept, is that all of these systems, we need to be talking to each other in better ways. It can't just end up, well, we need to find one system that does everything, which is impossible. So if we're talking about asset management for the life cycle, it's a pretty broad need, and all of the different solutions and vendors and consultants need to think in those terms of how do we create that value for the owner, like we talked about earlier from that.
This is just a quick ROI. If you're curious, we found that for a 500,000 project, 500,000 square foot project, if you're not using harvesting BIM to populate your FM and GIS programs, it's between 6 and 18 months, and at $50 an hour, there's a cost implication there. To create a BIM execution plan from scratch that includes data, there's a time and work effort there. To create the Revit templates used by the various trades, to create the content, again, collected, this is 36,000 components. It's a 2 to 4 year effort. And then they have to maintain that every year, because Autodesk is constantly revising what they do in Revit, and we have to update the templates and update the BXP and the content BIM execution plan. We've set up standards for HOK, SOM, NBBJ, AECOM, Denver International Airport, all of these amazing clients for the last 20 years. It's not just content out of the box, it's our best practice workflows of how to use this content, and has the data structure already built into it, standards, support.
Because we're showing obviously a connection between us, but all of this works with other applications too. Even though we're showing these examples, you work with a lot of different applications, CMS, others. So I want to reinforce that, and for us too. But the important thing is you have machine readable data. We have an agreed upon format. We can use industry standards like COBE or whatever, or structured formats that you have developed. And as long as the data communicates, we have the IDs that are tracking back and forth, which then allows us to quickly import them back. So we took the model that Cyril added to, and this, I guess this is the handover that we had. We handed over data, but we also handed over the XML file that Cyril mentioned. The XML file actually has the geometry as well, and because we're using the plugin, it's still related back to the original model that we had in Onuma. So it's not a new version of it. It's basically that continuation of that, and we can go back and forth, but we just did one pass back and forth. And I'll show a little bit of what that looks like in our model as well. So I'm going to switch over to my screen here. And there's a couple of themes here. One of them, I'm going to talk about the floors next too, Mike, because we wanted to bring that discussion in too. But yes, in the model, so this is in Onuma now, the exact same model, the data that Cyril was showing earlier. We have the exact same room here. We have the floor materials and finishes that I talked about, the air changes that we adjusted based on ChatGPT. So we're seeing the results of the AI giving us guidances. You better change the air change in this room, it's wrong or whatever, and the floor material. So one other angle to this too, and this is, we landed like I mentioned earlier, the building in Los Angeles City College. So this is actually, again, an Onuma system with a GIS background. So this is a clinic we were just looking at. In Los Angeles Community College case, this is an actual ongoing project with them on our other buildings. They're very interested in floor finishes because they're tracking maintenance and operation and custodial. How much time and effort do we need to spend on cleaning, and what level of service? Actually, they're using APA standards embedded in part of this process. How do we define what floors are? So knowing what the floor finish is, knowing what the maintenance on that floor is, knowing the size of the room, because that's critical too. If you just have an area of all these floors and all of a sudden you could say how many square feet of linoleum do we have or whatever, and it gives you a report, a summary report that says, well, this is your square footage. So these shapes, as far as assets goes, as far as spaces go, it's an asset of a space, of a building, and of the individual equipment in the building for the mechanical, and also for the property, that like the medical equipment. But let's zoom back into this one room that Cyril was talking about earlier. So now we're not inside Revit, we're not inside the system that Cyril was showing, but we're in this case, Onuma system. And if I look at an individual asset here, and I click on that asset and look at the attributes, I see, let's see, where is it? Purchase order. I did not enter this. This all came from Cyril's data, the serial number, all of that. So it made its way here, and we added, and we'll talk about barcodes and QR codes later, but essentially this allows us to see the same information now if we're shifting into operations, facility management and operation for the assets. I noticed that we zoomed in from a map, right? So there's latitude and longitude in the building, it's precise location,
right?
The shape, and now we're inside the room, inside the building, in a geospatial location with a very precise room number, and then an ID that has information that we use for facility management that tracks all the way back to what we talked about earlier. At the state level, they're managing for the entire state of all the spaces, but now if we're in an individual room, in this case, it's a building that it's a theoretical building, so we're not showing an actual construction in this case, but it's very, very similar to how they would think in terms of spaces in a building and how do we manage and maintain them.
And that same data could be used by the police or fire department or custodial or capital planning, space plan. I mean, the use cases are endless, truly.
In Los Angeles Community College District, the teachers are using it to know what rooms are available so that they can plan classes.
Exactly.
Or submit work orders. Yeah. And yeah, the data, for example, here, immediately while we have it here, we have and I touched on the APIs earlier, but there's what's called an API, which means other applications can read this data. So in the Los Angeles Community College's case, there's another application called DabbleFox that's used for custodial planning. They're reading the data from Onuma, but they're seeing it in DabbleFox. We're reading the room names and numbers from Fusion, but we're seeing it in Onuma. The data becomes neutral, becomes an asset of that owner, and then you use it over and over again, but we're all looking at the same source of information because every single owner that we work with struggles with this. They have different systems that have different room numbers, so they can't figure out where are our assets, which room we are. It's something as simple as that. It's not an easy thing to do, but as soon as you start wiring these systems together, then it becomes possible.
Yeah, it's
actually,
funny.
This is Thomas. Actually, even the planes that we have in Onuma are shown in the other application. So even the planes can be, with an API, can be called up so that in DabbleFox you can actually look at the planes that come directly from Onuma.
That's right. That's an important point too, because we want to make sure we're in alignment with what because DabbleFox is using the plans to count square footage for custodial planning. We're using the plans to count areas for other purposes, but it's the same shape. That 120 square feet of that exam room is the same shape and the same data. So this is another view of that clinic with different data associated with it, and then kind of a dashboard view that gives us information about each space. This is, again, same data, different view. Nothing really magical about a dashboard, but the magic here is that we're looking at the same data that Cyril was showing us just a few minutes ago, as far as spaces and information related to them.
Nothing magical about a dashboard, but it's hugely important because what it does is allow non-expert stakeholders to understand complex information. So I actually disagree, Kimon. Dashboards are really important.
Yeah, dashboards are pretty popular for that reason, because you can have executives actually seeing information that they don't want to see in a plan, for example. They want to see dollar signs and whatever cost associated with a space. So there's many different use cases for the same data. I guess that's the point here. So we mentioned at the very beginning that owner drives a lot of this. We need to design, construct, manage assets, right? We inserted a use case here in the middle of this for tracking total cost of ownership, which Deke Smith and Jack have been giving us input as well. So we said, okay, we want to start thinking in terms of energy. So if all the information that we fed into ChatGPT, we asked a question like estimate the energy use if we want lead certification. So it started spitting information back to us. Some of it is off maybe, but it's pretty close, a lot of it. At least it gave us an idea of what to look for. It started calculating how much water usage, this kind of stuff. Then we said, calculate the carbon footprint and extrapolate it to a 50-year life cycle. Okay, then it said, well, here are the answers for that. We didn't do a detailed quality check on this other than saying, well, that's interesting. It's doing stuff with the data that we fed into it. Now it's giving us carbon footprint calculations. And then we said, give us a total cost of ownership. What's it going to look like? Well, here's the things you need to consider. It gives some formulas. And then Deke gave us input. Let's see, where was Deke? Deke, let me jump ahead here. So we asked Deke Smith what his thoughts were on total cost of ownership. And he gave us some input. Well, total cost of ownership, we also need to think about natural disasters and how you deal with it. To take into account, well, there's a use case in Nicaragua where they had an earthquake and it wiped out every hospital. So the hospitals were not functional because they weren't planned to withstand the earthquake, which is basically an asset that wasn't properly designed, possibly, but that's a lesson learned. So in Nicaragua, they had a lot of issues like this after the earthquake, hospitals falling down. So it's a question about resiliency. In other words, there's a lot of different factors involved with making decisions about the total cost of ownership. So then our final question to ChatGPT is, consider everything you told us, 50 years. We have a calculation for how much this building is going to cost because we drove it out from the Onuma system, $7 million plus. What's the total cost of ownership with all the factors that you gave us? Actually do a calculation. So it started doing calculation. Then we said, put it into a table. So this is a table that it gave back to us. I don't know if these numbers are accurate. It's something to consider, but the initial design, construction, getting the building running is $7 million, let's say. And then ChatGPT said, well, here's the recurring costs, and we're getting a 45% savings on energy because we're using LEED. We're getting 40% on utilities, of maintenance costs. So it's showing us what the ROI is of spending that extra money up front to be able to plan for resiliency, for total cost of ownership, and for other factors. So from an owner's perspective, these are discussions that are important before the building is built, and also to plan for the whole life cycle. When you think in terms of an asset for the life cycle, these are things to consider.
So what's exciting about this is if you're like an executive in an organization, the people are talking to one another. The data is there, it's being shared, it's being evaluated, decisions are being made using good data and good communications. So that's an assurance or reassuring, the value of all this. I think, the challenge is people have to kind of get used to that operating environment and the understanding that this information is being exchanged and it's being curated in a way that's supporting decision making, and it's also established ways that have integrity. I mean, some of the points that come up is when you're exchanging information about a design activity with the operations group, you might not be ready to, you're not ready to go, this is the answer, to get the feedback. So that process has to be learned as well. So the technology is giving us a tremendous amount of power, visibility, integration, supporting communications. But what is also going to have to happen is we're going to have to develop new behaviors and learn how to communicate leveraging these tools. So as exciting as it is, and it is very exciting, and it will be changing our operating environments, we also need to be careful and understanding of the human in the loop activity, and ensure that they're aware and understanding of how this is changing things, So that way they can be confident as decisions are being accelerated in ways that we're still learning about.
I think one way for the owners to do that is to have these type of charrettes, these types of BIM storms prior to the project, and they could basically learn by doing.
Yeah, and as Kimon made the point earlier, you kind of have to start. You have to start somewhere, and it's a good time to start learning about these tools, because it is going to accelerate the industry, and people who learn how to apply them are going to be advantaged. Although it is going to take some time to figure it all out.
Yeah.
Yeah, 3 weeks.
No, needs more than that from here, but yeah, it's a good start. But what's interesting too is the whole ISO discussion from an asset management perspective. You guys, I've heard this from Jack and from ALN many times, but being able to kind of define what we need to be thinking of, right? And kind of create a standard around, well, here are the steps or things that you should consider. It seems like it fits right in with that as well too, I believe, even though I'm not an ISO expert, ISO 55000.
Oh, absolutely. I mean, the genius behind the ISO standards, management system standards, is there's a rubric, like kind of a single structure, they call it a harmonized structure, on how all management systems operate. That's the genius in there. And it's being applied across dozens now of topics. Quality management is a big one. People are familiar with that. Environmental management, asset management is coming on strong. But there's literally dozens of places within an organization about a management system that are all using the same rubric. So as organizations learn and understand that, it's an accelerator to integrate more and more parts of the organization to kind of bring all this information together. So it's right in step with the AI and this integrated kind of operating environment. And I think those management system standards, and particularly that rubric, are essential to make sure that that organizations are in fact behaving appropriately in terms of management systems. It is in itself a system, and it is a system for management. So I think there's great advantage there, and I think organizations will learn more and more about how these two kind of capabilities come together that will help move the ball along.
Yeah, that's great. Yeah, and these standards too, obviously they're very important, but they a lot of times people kind of from the outside it seems very complicated, but really the standard helps set the stage to describe in a simple format what to do, right? That's one way I look at it. So for example, the APA standards we talked about earlier, there's a lot of stuff happening in APA, but the end result, the use case is the custodial and maintenance staff on Los Angeles Community College campus know that they get a request that this room needs attention. They don't need to know all the underlying whatever, but it creates that consistency across the organization. I think that's the value there too.
Yeah, I think I mean, an analogy I've heard that I think really fits is, people put brakes on cars thinking that these standards slow you down. People put brakes on cars so you can go faster.
Yeah,
So the standards are really trying to protect ourselves about the speed by which we're operating, to make sure that we can go faster where we can, but we're doing it in a controlled way.
Right, exactly. Yeah.
So moving faster to being able to take the information that is in pre-planning and keep it through design and construction, and then use it for work orders. That's perfect.
Yeah. Okay, so we're at work orders now. So we're jumping way ahead into now the building is complete. But before then we said, okay, let's create a task. We actually created a task. Let's put some QR codes into that exam room and to the roof of the building where we had the mechanical. So we actually simulated that here, not simulated, actually it's live. The data from Cyril that we had about the purchase order and whatever, it's in the equipment like I showed earlier. We added QR codes to each piece of equipment. And we also, let me just open the screen. Oops, that didn't work. Got too many things going here maybe. Okay, so let's just keep it here. Didn't want to open on a separate screen. And then we have a QR code for the entire room. And this is actually active. I'm going to leave this on screen a little bit here. but I'll show you a little bit about how that looks. You can try this. Everybody can actually try this. It's actually open. So I have my camera here, and I'm going to go and scan this QR code. It scans it. It opens it up in this tool we call BIM Genie. BIM Genie is reading off the server that I talked about earlier, reading the information about that building and landing me in this space. See how it automatically populates? Okay, it knows I'm in the clinic, it knows I'm on level 1, it knows I'm in that exam room that we talked about earlier. And this use case here is I'm an occupant. I know nothing about BIM. I know nothing about facilities. I know there's something wrong with the floor. The floor has a hole in it. And then I'm gonna put my name in and my information, and that's it. Basically, I could put more information in there, but I can hit submit. And what this does is it sends a request. Thomas in the background here is acting as the admin. So I'm just the occupant. I'm the teacher in that room, or an occupant in the room, a student, and I've submitted a request. So it says, thank you for your request. You'll get an email. And now I'm tracking. So this is real-time data now. We're in digital twin territory now, right? Because we're using the data that was harvested, like Cyril mentioned earlier. We're live in the building and we're interacting with the model. We're interacting with the assets. We're interacting with the facility teams. And we're talking about the floor that has an issue that we need to be replaced possibly, like we talked about earlier. Maybe this is a floor that is damaged and needs replacing. We need to find out what kind of floor goes in that room. So we need a database. What's this original specification? What's the performance required to be able to support an exam room? So that's one use case. And when I open up the work order, and I'm flipping different hats here, but now I'm seeing it as an admin. Go away from the iPhone view and looking at our desktop. Now I'm starting to get the requests that just came in. So these are requests that have been submitted today. And I could open that up and I can assign that to a technician, go and check the floor. Okay, I see as the admin, somebody submitted, I can see the location of BIM, even though the admin doesn't know anything about BIM, they know about facilities. They go, yeah, that's the room. Let's see, there's some kind of components in that room. There's something in that room that has whatever, there's a component. So I can see all the assets in that room. There's a computer and a side chair if I'm talking about that, but here in this case, we're talking about a floor. And I can say, I'm gonna assign this to technician. Oops, sorry.
Yeah, you already assigned it to yourself.
Oh yeah, I
so
assigned
you
it
have
to
to
myself.
reassign it.
Okay, I'm gonna assign it to Ryan. And save and return. So anyway, that's just a glimpse of what happens with this data now at the facility side, managing, like we talked about with APA standards for the custodial, managing the response to the request that was sent in. And if there's another room, that temporary clinic that I talked about earlier, again, in the simple interface, we can dive into that building and load the room, point to the room and say there's something happening in that room and go through that same process again. This is exactly the way we're dealing with a lot of thousands of work requests like this and preventive maintenance and work orders in our system called the BIM Genie. But I want to stress again that the output from Revit that Cyril showed can also go through COBie into other CMS systems. So this is not the only solution. The difference here is that we wanted to show the live link all together and to give you access to it if you'd like to submit a request here. The technician that walks into the field and walks into the room, now they have QR codes on each individual equipment. So if they don't know which one is the defibrillator or whatever they're looking for, they can scan it and it'll pull up the purchase order, the warranty information, other information about it, and then interact directly with the requester. So it's a real-time connection back to the original request. We have the same scenario set up on the roof for mechanical equipment, mechanical assets. So on the roof of the building, we have, oops, I did the same thing again. Sorry, I'm hitting the wrong buttons here. We have equipment set up that, oh, and by the way, this equipment was recommended by ChatGPT. We said for this clinic, with these kind of LEED Platinum goals, what kind of systems should we consider to put in the building? And some of them are whole systems, some of them are actual equipment. Give us IDs and we fed that back into the model to actually place objects on the roof, which still need some engineering decisions, but at least we have a line of things to consider, including a photovoltaic installation to generate energy. So this is one result of the AI basically giving us recommendations to meet, lead, whatever, and then us putting that back into the building. I'm moving this thing around, so I'm messing up the layout, but anyway. So if anybody wants to try and get to the roof as well, you can actually scan this and get to it as well. So we covered a lot. There's a lot more. Actually, that's one thing we need to emphasize here. There's a ton more stuff that we could show. There's a lot of stuff in the background, but then we get into the weeds. We're very happy to have any follow-on discussions through ALN. I think, Mike, you were interested in setting some things up, but that'd be interesting to see where else can we take this. This is still an experiment, although everything that we showed you is actual real-world scenarios that are actually happening in our work. We're sharing what we're doing, and then we're exploring where else this can go.